I think is the best inspiration for all of you. Faraday's law is one of the best things. I suggest you today, rather than doing something, put half an hour, try to read about the Faraday's law, the history of them. So if you look at the Faraday's law, almost 18 years, for 18 years, okay, it says from London. So there, the Royal Society, they're given a room. He had a room, particular thing. And whenever people saw him, they saw him that he was carrying a bar magnet or shoe magnet and bar magnet and a loop and in his pocket, and it's a London, it's a cold country, maximum temperature 60, no. So in that particular jerkins or what you can call coat, no, in the pockets used to carry magnets, different types of magnets and different shaped loops. And whenever people saw him, they saw him that either magnet or loop, trying to move them together or keeping there and trying to move that one almost for 18 years per day, 10 hours. So definitely if it's India, what happened, we will complain that he's a mad person, we would have put in jail. For almost for 18 years, people watched him. Some books they say 14, some books they're selling 18. We'll take maximum. We'll take maximum or average 16, let it be. For 16 years, for daily 10 hours, people saw him that he was just spending time with bar magnet and these loops, different types of bar magnet, different loops, and all. He was moving them, thinking on them, how it will come, how it will come. And he used to have a paper, pen, and used to write some equations, then that one. And you see the number of papers at that time were costly, but he used to use pencil and eraser and used to erase it, that one. So they saw that almost, if you count nowadays the using papers, no, it is coming around 11,000 papers, A4 size. Those many papers, what happened, he has scribbled to bring this law. I'll finish off within 5 minutes. And there's one basic law on which we are surviving. The modern science and technology just revolves around Faraday's law, electric power, based on Faraday's law only. What all we have, the whole our life revolves around the Faraday's law here. I think how important it is. When you don't have electricity, you can feel, not 1 2 hours. When I was in Vishakhapatnam, Hudud Tufan came. Almost for 10 days, we didn't have electricity. So no electricity, no water pumping, no milk, no electricity, no petrol. No petrol means no transportation. So no vegetables, no fruits, no grocery. Then what about water? We used to search for bore wells. Where all bore wells are there, we used to stand in a queue and we used to get fetch water, 4 5 pots of water, salt water or fresh water. We don't know. Something water is needed. And no bath for 3 days, 4 5 days, 4 days, no bath. Things have stand still. 10 days no electricity, no, things have gone, everything. And no shops, because no electricity by 5 o'clock, 6 o'clock, they used to close. So without electricity, I don't think so we can survive this comfortably. Can you listen? So it's like a modern world. What happened now survives because of electricity. And what all electricity is there? Because of Faraday's law. So what he has spent his time, no, that one. So what we are enjoying. So please do read. So it's an inspiration for that. The hard work or the effort what he has put. Constant thinking on a subject is the most essential. When you don't get a problem, you have to put effort. You have to constant thinking is needed. So what is the method nowadays we are learning? The moment you see question, you want answer, because that's what advanced training, no? The training what you are getting for advanced maths is of like that. And the moment you see question, you should get answer. But science and technology demand something totally different. The way what training you are getting and what science and technology needs are totally different. I'm making things a little bit clear for you. Constant thinking on any subject, you can master it. There's a rule of science that we are fast losing it. What we are thinking is something, you must have intellectual ability to crack that problem. Nothing that one. If you look at the Faraday's law, if you look at his school progress report, everything, no, nowhere he was topper. Nothing to do that one. So the school education and what all he invented, they are not related. So better you can say like he went to school but never interfered with his education. The future, your future will not be like problem solving what you are. Of course, this problem solving skills will help you, but the science and technology demands something very different: patience, hard work, constant thinking on a given subject. Then only what happens, some you can make a breakthroughs just by instant things. In science is not instantaneous, that much I can say. All invention, discoveries, or the new applications come, they're not instantaneous. Constant thinking on a given topic is very important. So nowadays, that particular thing, we are fast losing it. Exponentially, it is decreasing. Maybe after, if this coaching continues like that, we don't get any thinkers in India. It's over. Every day it's decreasing because the way you are learning, no, it's against the science and technology. So and I'm a part of a cycle. You can blame your teacher also, blame administrators, blame JE, IITs, everything. So in spite of this, you must like a focus on your future. So you must develop a skills which are needed for future. Constant thinking on any given topic, you can master it. There's the one golden rule of science and technology. Do read today on Faradays. I'm telling this one. Today you read on Faradays. It's really very inspiration. Anybody can learn physics after reading. Is the life, is all the efforts, everything. No, you feel, oh, anybody can learn physics. What is there in that one? A very simplified way you can conclude, and that will help you a lot in for your future. Anybody can become engineer. One who puts effort, will become engineer. Okay, let me come to the syllabus. So what this Faraday, so after putting effort for almost on and average 16 years into 10, you multiply, I think how many hours, that one. So if finally proposed a law. So what if telling? An EMF induced in a loop is directly proportional to rate of change of flux. By this time, all of you have idea of flux, magnetic flux, rate of change of magnetic flux. Better, right? Now you know enough information of EMF, magnetic flux. I think these are the words already you have encountered. EMF, electromotive force. What that electromotive force will do? It will make the charge to go round in a loop. This one, no? A force which is responsible for the flow of charge around a loop, and due to that, there'll be due to flow of charge, rate of flow of charge constitutes current. So what does it mean? Means when a flux linking a loop varies with the time, then an EMF is generated in loop, and that EMF is responsible for flow of current. It's what the Faraday's is telling. So what all we have today, electric power generation, they're just based on this Faraday's law. So the formula, so is EMF induced directly proportional to d phi by dt, or the law is this one. So where n is number of turns. Negative sign, the induced EMF negative sign is due to Lenz's law. So the negative sign there. The negative sign indicates the induced EMF. The induced EMF opposes its own cause. Negative sign indicates the induced EMF opposes its own cause. So there's nothing but the Lenz's law. Let me put that Lenz's law here only. So what is the Lenz's law? The direction of induced EMF or current in a loop is such that it will oppose its own cause. such that it will oppose its own cause. The direction of induced EMF, so this direction of induced such that it will oppose its own cause. That one. That's what the Lenz's law. The very exclusively we are explaining that particular negative sign by using another law called as the Lenz's law. Okay, let's take that physical meaning of this. What is the interpretation of this? So let me take a loop, that one. So let this be a loop. B bar, let it vary with the time. So the side length of the loop is L. So according to Faraday's law, an induced EMF is set up. So from Faraday's law, let's go for this. E equal to, let N be the number of turns, equal to magnitude. Let me calculate first. So d phi by dt. What is flux is equal to? We define B into L square. So N L square dB by dt. This will become B naught. So N L square B naught. So this is the EMF induced. Because of this, what happened now? The loop, what happened? I can bring a cell. I'll introduce a cell. So what this cell will do? It will push a current. So what is this C? I can bring it here. Let R be the resistance of loop. So what is the total current? I is equal to E by R. You connect any bulb here. I'll connect a bulb. The bulb starts glowing. So how to produce variable magnetic field? Have different, we know Biot-Savart law, Ampere circuit law, we know enough, we are very good in magnetism. So we know how to produce a field which varies with the time. And I'll make that field link this particular loop. Then the bulb starts glowing. So what this particular loop is converting? It is converting magnetic energy into electrical energy. Magnetic energy into electrical energy. With that electrical energy, what happens? The bulb will convert electrical energy into the light energy. So what is that value of E is what I'm putting here. And here the B bar will vary with the time. There's a one way of producing the induced EMF. So what I do, I'll make the B bar linking a loop varying with the time. That's what the Faraday's law is telling, d phi by dt. Now, what is another alternative method? I can also take help of, I should make the flux to change. No? So let me take these are the long conducting rails. There's a R or bulb. So let this be a rod. And let B bar be constant. This one. I will project this rod with a velocity v. These are rails, railway track rails, no? So at a certain point, I'll connect by resistance at one end. And there's a rod. Now I'll project with a velocity v. Now what is the flux linking it? Let x be the length of the rod from the resistor rod. So what is the expression for flux linking? B into length of the rod, let it be L. So B into area, B into L into X. I differentiate this d phi by dt, BL dx by dt. I'll move the rod with a constant speed. So now I'm getting an EMF induced. How much is equal to BLV? With what speed you move the rod, based on that, the amount of EMF will be induced. So this moving rod, now this entire circuit, there'll be a flow of current. So where should be that EMF? So this moving rod now will behave like a cell. an EMF will be generated. How to predict direction of current? That is from Lenz's law. Time being, okay, just accept here. The current will flow like this here. Now what we are doing, just move, how to move rod, as we are very good in mechanics. I'll move the rod with a constant speed. Now instead of resistor R, you connect a bulb here. So let this be a bulb. Instead of resistor, let this be a bulb. So what happened to this bulb? This bulb starts glowing. It's quite very easy to generate electricity, no, with this mechanism. You want more brightness, increase the speed of the bulb, and there'll be friction between the rod and the rails. So take care about all that particular thing. So there's a one way of generating an EMF. So what we are doing, B is constant and angle between B and S also constant. What we are doing is we are just increasing the area of the loop. So third one, the third part of the situation, so let this be and let's be a loop. And let B bar be directed into the plane of the loop. And I'll rotate the loop about this vertical axis, passing through its center. Then definitely I say that there'll be EMF induced. How it is possible? So what is the flux? B bar dot S and Bs cos theta. And what is the angular velocity of the loop? Angular displacement by time. So this we can write it as Bs cos omega t. I'll differentiate this d phi by dt, which is equal to Bs omega sine omega, and we know EMF equal to d phi by dt. So Bs omega sine omega t. So this is quite easy, no? Just you rotate the loop in a magnetic field. Who will produce that magnetic field? Uniform field. I'll take help of current carrying sheet. Nearby current carrying sheet where field is uniform, I'm going to rotate a loop. This you say copper loop. Then the field I'm going to get it. You connect a bulb to this, the bulb starts glowing. So what are the three mechanisms? Either B bar linking a loop, you can vary with the time, or change the area of the loop, or change the angle between the B bar and the area vector of the loop, or B bar and end cap. So we'll get EMF. So can I vary all three? Yes, you can vary any two. So how you can produce EMF? You can vary any one. So what we have is formula. Look at this one. How to make flux change? The flux depends on the field strength linking the loop, area of collection loop, and the angle between B bar and end cap. You can vary only B bar. You can vary area of collection loop, or you can vary angle between B bar and end cap. You can vary any two. You can vary all three also. So what are the type of numericals you're going to get? The first case only B bar varying, area of collection of varying, or the angle between B bar and end cap will be, or any two, or any three. So like this, problem related to all these different kinds will be available for you. So first initially we are at basic level now, we'll just assume only these three cases here. So like this, by how to vary flux linking a loop, these are the methods what we have proposed it. Any loop, I took a square loop here, it can be a ring or anything. Provided the flux linking the loop should change. So here look at the end cap. Initially let end cap be along native z axis or into the plane. So as the loop rotates, what happens, the angle between B bar and end cap will change, no? I think you know enough of rotation mechanics. You take notebook and start rotating, and you take one reference plane. So what happened to that angle made by reference plane with any other reference what you take will continuously vary with the time. So therefore the flux linking will be varying here. So like this, what happened, we can produce an EMF here. So after this, let's come for the idea of Lenz's law. So what is the Lenz's law says? The direction of induced current or EMF is such that in a loop is such that it will oppose its own cause. Okay, now what is induced current? This I is called as induced current. I will start with this example. It will be very easy for you. A current I flows. Tell me what is the cause? velocity of the rod is a cos. Velocity of the rod is a cos. What is the cos? I'm projecting the rod with a velocity v, or I'm moving the rod with a velocity. This is a cos, no? This is the cause for changing flux. And what it says, the direction of induced current is such that it will oppose its own cause. So now the current should flow in such a way that it should oppose the velocity, motion of the rod. How do it can oppose? You go back to the Ampere circuit law, a current carrying rod in a magnetic field. Left hand, Fleming's left hand rule, F equal to BIL formula. Put pointing finger in the direction of B bar. Current I, twist, I think you have to twist your left arm. Don't put like this, twist your left arm. That one. Current and the middle finger in the direction of current. Look at the thumb. Thumb will point towards left. And what is this? This is the BIL force, no? It's a force. And how it is acting opposite to velocity. That's what the Lenz's law.